Today I'm going to show you how k0s, an open source Kubernetes distribution from Mirantis, enables teams to deploy complex applications with the simplicity developers expect and the reliability operations teams need. k0s is a lightweight, production-ready Kubernetes platform packaged as a single binary. It's designed to reduce setup, eliminate overhead, and make Kubernetes easier to adopt, whether you are running in the cloud, on the edge, or on your laptop. To demonstrate that, we built and deployed a small chatbot that gives basic text responses based on user inputs. We'll take it step by step. First, we build a Docker container for the chatbot and test it locally. Then I'll show you how to deploy it on a k0s cluster. And finally, we'll take it to production by pushing the image to GitHub Container Registry. Before we get started, let's take a quick look at our project structure. The project is organized into three simple parts: a Flask end that loads a GPT-2 model, a basic HTML front end, and a couple configuration files defining how to run our app on Kubernetes. This kind of lightweight and modular structure reflects what k0s is all about: clean, minimal, and easy to work with. Now that we understand the project structure, we are ready to build the chatbot's container and test it locally. This process bundles our code, the GPT model, and dependencies into a portable container. Once the build is complete, we run the container on our local machine. This launches the app's backend at localhost 5000, and we can open the front end in the browser to start chatting with it. Next, we set up the Kubernetes configuration. We have two files, one for the deployment and one for the service. These files tell Kubernetes through k0s what to do with our app. The deployment file acts like a blueprint. It makes sure our GPT-2 chatbot is always running and alerts at scale if it's needed. The service file handles access. It maps the internal port like 5000 to a public address like local 30,000. So we can open the chatbot in a browser from outside the cluster. Now comes the exciting part: deploying our chatbot to k0s. We begin by launching a local k0s cluster and check that the node is active. After confirming the cluster is ready, we package our chatbot image and load it into the k0s container runtime. This makes the image available for Kubernetes to deploy. Then we apply the configuration files we set up earlier. This tells k0s how to launch the chatbot and expose it to the outside world. With everything applied, we check that everything is running as expected. Now the application is live and the service is ready to handle requests. At this point, the chatbot is fully deployed inside a real Kubernetes cluster and can be accessed from the browser at localhost 3001. The beauty of k0s is how fast and lightweight it is. It removes the usual complexity of setting up Kubernetes so you can have a working cluster up and running in minutes with almost no overhead. Once the app is working on our local cluster, we are ready to prepare for production. To do that, we'll push our container image to GitHub Container Registry. We start by tagging the image and pushing it to our GitHub account. Then we add the necessary pull credentials so Kubernetes can access the image securely. Once everything is in place, we apply the updated configuration and k0s pulls and runs the production-ready version of our chatbot just like before, but now using an image hosted on the cloud. To recap, we build and deploy a GPT-2 chatbot starting from local development all the way to a production-ready Kubernetes cluster using k0s. This shows how easy it is to move from testing to production with consistent workflows, no extra tooling, and zero friction along the way. Whether you're building alone or at scale, k0s makes Kubernetes simple,